All right, so continue. What did it say?
77 million people were born between 1946 and 1964.
Okay, so 77 million baby boomers. Yes.
According to the census. It is said that today and every day for the next 18 years, 10,000 baby boomers will reach 65.
10,000 turn 65 each
day
day.
for the
Okay.
next 18 years.
Okay.
And then it goes on to the actual problem.
Okay.
1/4 of this uses email and so on.
Hang on. 1/4 use email. Okay.
1/5 gets their news from the internet.
News on internet. Okay.
1/6 searches the internet.
Okay.
So I guess they don't find the news. It just says they search the internet.
Mm-hmm.
Okay, and then it goes on. Find the lowest common denominator and determine the total
Find
technology
LCD
usage.
and total tech usage
As a fraction.
as a fraction. Good. Okay. So.
Now,
Mm-hmm.
what made me think about this was, do we even need any information from this problem up to the 10,000 figure?
No.
We're not using 77 million, we're not using 18 years.
Nope.
We're not using each day.
Nope.
We're not even using 65.
Just
Nope.
We're
using the
using
fractions.
10,000.
We're not even using 10,000.
No, we're just using fractions.
Yeah.
Oh.
So all of that information is very good information to know, right? It's very good to know that there are 77 million baby boomers out there, folks, right?
But it has nothing to do with our problem.
But for the actual question, did it ever ask you how many baby boomers are doing anything?
Determine the total technology usage.
As a
Or
fraction,
this
not
age group.
as a number, as a fraction.
Oh,
So
I
what
thought you said this
fraction of them are using the internet? And again, it's a slightly poorly worded problem because, of course, you don't know that each one of these are mutually exclusive sets, right? Is someone who uses email also someone who gets the news on the internet? It's implied that they're all independent. And so that each one of these, in order to figure out the total, how do you figure out total, folks? What do you do? Add, okay? And so why do you think they asked the first part of that question, which was find the least common denominator?
So you can add the fractions.
So that you can just add the fractions and you'll get the answer relatively quickly. Okay, so yes, this is definitely something that happens relatively often in the real world, folks. You're going to get more information than you need. Your job is to throw away the stuff that doesn't necessarily need to be used, okay? And that will definitely be something I do as well. I'll give you more numbers that you need in order to do a problem. And you have to know that this one is not necessary in this instance, okay? So don't feel like you have to use every number I give you, okay? Don't. It's like doing a Google search, right? If you've ever Google searched anything, do you just get one result that only has one piece of information on it? If you ever have, you're searching for something very specific, and I don't want to know.
That's a whole nother class.
So in this case, we're just looking for the total tech usage. So all we really need to do as a fraction is just add the fractions. And so what was the least common denominator?
60.
60, as it turns out. Again, you didn't have to use it necessarily, but it does make it the most easily used number, right? So how does this convert to a 60, right?
Turns to 15 over 60.
Uh-huh.
The other one's 12 over 60.
12, uh-huh.
And 10 over 60.
And 10 over 60.
And 37 over 60.
There you go. 15 sixtieths plus 12 sixtieths plus 10 sixtieths.
So
37 bits.
guess what?
You got
I
it,
used the 10,000 and I still got 37 over 60.
Yeah, that's what I did too.
And that's fine. There's nothing wrong with it, right? I mean,
Well, I
if you,
didn't have to.
yeah, you didn't have to. That was the whole point. I mean, it wouldn't have been wrong to say that there were going to be however many that searched email, and then so you got like 250 of them that did that, or 2,500 and
Yeah.
2,000, and then you said, well, what are they as a fraction? It'll turn out to be the same thing.
Okay. But it was a little extra work. Okay.
Yeah, it was probably more than a little, but
Yeah.
it was okay, right?
Chap, they had a question.
My problem was number 42.
Same thing.
42?
Mm-hmm.
What was number 42?
The local Target store bought 90 pizzas at Pizza Hut for its holiday party.
90 pizzas.
Each guest ate a sixth of a pizza, and there was no pizza left. How many guests did Target have for the party?
1/6 of the pizza. How many guests?
I came up with an answer, but I wasn't sure if I actually did it right and if my answer was right. It seemed kind of low.
Alright, so how are you going to attack this problem?
Well, the way I did it was 90 over 1, turned it into a regular fraction.
Okay, well, but this is a word problem.
Okay.
What's a good technique to try and attack word problems? If you don't know what to do,
Break it into pieces.
break it into pieces. You've got 90 pizzas. How do you show that you have 90 pizzas?
Oh,
I've got 90 pizzas, right? I mean, and if you really, really want to, you could put pepperoni on them, or sausage, or if you're vegan, or if you're vegetarian and you only want to have veggies on it, that's fine. Put on broccoli and green peppers and onions and
Can't have cheese.
whatever, right? Again, have fun. But now that's the first piece of the puzzle. 90 pizzas. Now, what does the next thing tell us?
Just each 6 of the pizza.
So, what would you do with each one of those pizzas?
Break it down to a 6.
Yeah, you'd say, hey, each pizza now has 6 pieces, right? Because each one of those pieces represents
Yes.
one person, right? So what's going to happen with the second pizza?
Break it into 6 pieces.
Same thing, right? Third pizza.
Same thing.
How many pizzas do we have?
90.
If we've got 6 people per pizza and 90 pizzas, what are you going to do?
Times.
6 times the 90 pizzas.
Holy crap, I got that way wrong.
Now,
Oh, not done.
well, no, that's a perfect analysis of the problem. It's not the way you should do it mathematically, okay? But this is a perfectly good systematic analysis of a word problem where you've broken it down to an easily done mathematical analysis, right? Because you know that you've got 90 pizzas and 6 people per pizza. And so 6 times 90 says there's 540 people. Now, I'm a mathematician, guys, so I'm going to break it down the way a mathematician would look at this, or a physicist would look at this in a more generic case. Because what are we really doing when we say that each person eats a 1/6 of a pizza? We are going to divide these pizzas into 1/6 of a size. So how do you take 90 pizzas and you divide it into 1/6 of a piece? How do you divide, Steve?
When you flip the 1/6 to 6 over 1.
You flip the 1/6 to 6 over 1, and notice what you wind up doing. So your division is really multiplication, right? So either way you look at it, once you get to the end, you're getting 540 guests either way. All right? All right. So again, this is one of those where, and this is one of those where drawing pictures can help. All right. Feel free to draw them. And in fact, that's the number one rule that I tend to tell students when it comes to doing word problems is try and draw a picture. Right? If there's any kind of visual analysis that you can do, that's where you want to do it. All right. All right. Not too bad. I'll do one more for you if you ask.
Number 12, please.
Number 12? Is that the least common denominator one?
I can just scroll down real quick while you're waiting for an answer. Thank
Just
you.
write down 72 for that one. I don't care about least common denominator.
I just wrote up 70.
I do not care about least common denominator. Okay? Even if you said 36, I would give you credit, honestly. That problem I just give everybody the points for, but... Yeah, the method that the book uses to find least common denominator, they're nice, but I don't care about them, so don't worry about it.
What's that in your homework? You don't care.
Do you want us to write down the prime number?
No, not me.
Want to teach the rest of my classes?
Well, I mean, you had enough other things to worry about than to worry about that type of thing. Right? Like I said, the things I care about in this class are the word problems, okay, folks? So you should assume that the tests are going to be much more like the word problems than all of those sort of first beginning portions of every homework, which are kind of do the rote calculations of things, add, subtract, multiply, divide, that kind of stuff. Tests are generally going to be word problems almost always, okay? All right, so not too bad? Okay, so was there any other one that was mildly painful? Are we good?
Not had a smile yet.
No, I hadn't. Actually.
Oh, okay. Well,
Don't worry about it.
I marked the wrong thing and put the number 46 because that was written there. So.
Don't worry about it. You good? Okay then, folks. I would love it if you would feel comfortable enough to hand those particular papers in. Please note, folks, that I have been nice to those people who have not been able to make it here because of the snow and told them that they can turn it in on Monday. So I'm not being unfair. I'm just trying to be understanding of people that have further to drive than perhaps you guys do.
Oh, here's the sign in.
Yeah, use the top one, sorry.
Guys, don't forget to do alphabetical order.
I'll help. You want alphabetical first name or last name?
Don't worry about it. I can
So I
handle
go
it
over
this
you
time, I
and-
swear. Oh, there are no staples left in the stapler?
No. It's out.
Oh.
Give it a Zach. Give the wag Zach, make sure it works.
Does it work?
Yeah.
Okay, cool. Thanks.
No, actually, that's no.
I've read them in fractions also, most of them decimals and algebraic expressions.
Is the U.S. the only country that uses fractions?
No.
Fractions. Yeah. I mean, they don't use them as much as we do because we deal in halves and quarters and eighths of an inch. The rest of the world doesn't do any of that crap. The rest of the world deals with meters, centimeters, millimeters, microns, and all those other things. They don't, and they just move decimal points, right? That's the rest of the world doesn't muck with fractions as much as we do. Apparently, we really, really like it. All right, so folks, chapter 3 is basically getting us into decimals. So what I like to do to start with this one is just remind you how to read numbers. Again, remember that technically when you're reading numbers, the only time you say the word and is when you get to the decimal point, right? This number is 42,157 and then when you read the numbers to the right of the decimal point, you read them like they are to the left of the decimal point. It's just another number that's exactly the same as the one before, right? So 42,157 and 65,912, and then you say whatever place marker this last one is, 100 thousandths. Okay? That's technically the correct way of reading that number. Okay? So any numbers to the right of the decimal are read entirely like they're to the left, except instead of stopping, you put that place marker name at the very end of it. And remember that the way it goes, right? Tenths, hundredths, thousandths, 10,000ths, 100,000ths. It's exactly the same as to the left of the decimal point, except for one minor difference, right? There is no such thing as the oneths place, right? So it's a little bit annoying because if you're asked to round things to the hundredths, you round it to 2 decimal places. But if you ask to round it to the hundreds, you round it to 3 numbers over, okay? It's a little bit weird, but that's just what you have to get used to, okay? What I tend to tell students is that numbers are symmetric about the ones place, right? If you drew a line over the 7 here, everything to the right is always the same, right? Tens and tenths, hundreds and hundredths, thousands and thousandths, 10,000s and 10,000ths. Okay? That's the way we tend to talk about math in lots of other places, is sort of the symmetry behind it. Alright? So, technically, that's how you read numbers. Please note, you will not be asked to read numbers on the test, so it's not a testable thing. But it's just a good thing to remember. Okay? Alright, now. You will be asked to round numbers, folks, so you need to know how to do it. How do you round this number to the 10th place?
It would be the 6, and the one next to it is 5 or greater, so it turns to 7, and everything after it becomes zeros.
Exactly, right? So when you're working with the 10th place to round there, you go to that place marker and just look one number to the right, right? The number to the right of it is a 5, 42,157 and 7 tenths, because 5 and above round up, 4 and below round down, or round the same. All right? So, if I ask you to round to the thousandths, so again, go to the thousandths place and do the same thing, okay? Do not let the answer before you confuse the answer you're finding now, though, okay? So this is like it never existed, right? So this goes to 42,157 and 659 thousandths, okay?
You don't have to put the zeros afterwards?
No.
Oh,
And in fact, technically, you really shouldn't.
oh.
When you're writing numbers and are asked to round to a specific place, you always stop at that place. And that's how you tell people, that's where I rounded to.
Oh,
If you put the zeros after it, then it makes it look like you rounded it to that
the zeros.
last 0, and technically that's not what you did.
Okay.
Okay? It's a nitpicky point. It wouldn't be wrong if you wrote them, but you're skirting the edge.
Oh, okay.
Okay? Alright, so not bad with rounding. Okay, I don't necessarily want to beat a dead horse on it, but I do want to make sure that you guys can do all of that and handle it. Alright, so we came from fractions to get into decimals. You guys know that this is true, right? What's my question?
How'd you get there?
Yeah, how'd you get there? Yeah, how'd you do that?
1 divided by 2.
Yeah, how'd you do that?
Take the numerator,
How'd you do it?
1 fraction. Well, 1 division T. 2. Oh, yeah. Oh man, he's gonna make us do it the long way.
Yes, I am, because please note, folks, that the first test in this class,
Oh, I know how.
you do
Okay.
not get to use your calculator for a certain portion of it.
Oh, fudgesicle.
And that means that you have to be able to do stuff like this. Convert fractions into decimals old school. Okay? So please remember how to do your long division, right? So you take your 2, you divide it into 1, and add as many zeros as you need. Don't forget to do your division. How does it work? You say, oh, well, it can't go into the 1. The decimal point always moves straight up above. How many times does 2 go into 10? 5 times. And as soon as you get a 0 remainder, then you're done. And you can say this is why it's 0.5, right? So this is actually how you show students who are in 2nd and 3rd grade how to deal with fractions and decimals and how they are always related entirely, right? And so I'm going to ask you guys to do the same thing, okay? So, convert 3/40ths into a decimal for me. So now that you've seen the pattern, you can just follow it. Just be careful, right? So here's where you sort of remember the rules, right? Okay, so we're going to do it the same way we did it before, right? 40 divides into 3. Put as many zeros as you need. You can put them in beforehand or you can put them in as you go. It doesn't really matter. All right, but here's where you have to be careful because this is where you have to remember how division works, right? First off, can 40 divide into 3? Obviously not. Can 40 divide into 30? No. Okay, good. So technically, what number goes over the 10th place? 0. And that 0 is important, folks, because it's the first number after the decimal. You can't make that one just go away. Okay? So keep your zeros when you need them. Now, how many times does 40 go into 300? 7. 7 times 40 gives us the 280. 300 minus 280. Not 0 yet, folks. What do you get to do after you subtract? You get 1 free 0 dropping down. And then how many times does 40 go into 200? 5. And the nice thing about that is that it's exactly even once you get to 0. Now you have a terminating decimal, and there's your answer, right? 3/40ths is the same as 75 thousandths, or 0.075. Okay? I'm going to expect you to be able to do this, folks. Okay? Without a calculator. Alright?
So if it was 3/4,
Huh?
not 3/40, but 3/4,
Huh?
you could look at that and you could say 0.75.
Yes.
So is it just coincidence that this is point? There's instead of 4 at the bottom, it's 40, and then here instead of 0.75, it's 0.05.
Oh no, it's very much so related, right? The whole point.
So if we knew that law, we could just look at it and say.
Yeah. This is 0.75. This is 0.1.
So we're moving there.
Very much so. I mean, I don't necessarily expect you to do analysis like this, but that is very much so what you should start seeing.
So that's the law that allows us to move the decimal and put a 0.
Essentially.
Cool. But they don't always work out like that.
Well, if we did 3/8 and 3/80ths, it would work the same way. I mean, if the numbers are not, if it were unpleasant numbers. So let's do another one then. Let's do, this is a classic one. My mother used to do things like this to me all the time, by the way, folks. Convert this fraction into a decimal.
I'm thinking of the old-fashioned albums that went round and round.
33, 44s, RPMs. So how would you do this? Do you do it any differently? No. So we're going to take 3, divide it into 1, put as many zeros as you need. How many times does 3 go into 10?
3.
3.
Makes it 9. Bring that number to 1. Bring down to 0.
How many times does 3 go into 10?
Eventually you end up putting a line over the 3 that indicates it keeps going on.
But when you're 6 or 7 years old, and your mom's telling you to do this, and you say, Mom, it's going to be the same thing over and over again. She's like, no, I won't. Keep doing it. Until I finish the dishes.
There you go.
Ouch.
I had a big, huge paper. I'm like, Mom, this is always going to be 1. It's just 3 over and over again. She's like, great. Now how do you write that so that so that everybody else knows what you're doing? I'm like, I don't know. Do I just write 3s forever? And she's like, no. Here's how you do it. So when she finally finished the dishes, yes. Note, folks, when you see the pattern is repeating, put the repeating bar over the 3, okay? I am going to tell you on all problems where to round things at. If I do not tell you to round them, that means give me all the digits and make sure I know what you're talking about, okay? So, generally in a math class, I expect exact answers. So if I ask you to convert this fraction into a decimal, and you just write 0.33333 and then stop and don't put a bar over any of the 3's, you're wrong, because you have rounded that number. You stop going. It needs to be infinite. This bar tells you that the thing is repeating infinitely, okay? So, just keep that in mind. So, how about let's do another one then. Let's do, say, 1/6. So we don't do anything differently, right? How many times does 6 go into 10? Once. 1 times 6 is 6. 10 minus 6 is 4. Drop the 0 down. Keep going. How many times does 6 go into 40? 6. How many times does 6 go into 40? What's going to keep happening, folks? So how do I write that decimal so that I know what I mean? Yeah, so note, folks, here's the repeating, but note the 6 is repeating, the 1 does not. Do not put the bar over the 1. Okay? Be careful with that. Alright, so let's see. Let's try another one. How about 4/11ths? 11ths are another one of those annoying numbers, folks. I will like them, you will hate them. See it? Okay, good, right? 3, 33, 7, 0, 11 to 76, 66, 4, 0, 11 to 43, 33, 7, 0. What's going on, folks?
Repeating pattern.
What's repeating?
3 and 6.
The 3 and the 6. So how am I going to write that? Yeah, that's when you put the line over the whole thing. When the 3 and the 6 repeat, they both get the line. When it's just the 6 repeating, just the 6 gets the line. Okay? So that's how it works. Now, there are some annoying numbers in the world, folks. This one's not too bad. 11s really aren't all that bad. The one that's really, really, really annoying. Turns out 7 is one of the most annoying mathematical numbers that exists. And of course you should realize right away that I of course love it. Because it's annoying. Because I love annoying math. All right, so this one's going to be a little bit more challenging for you to start seeing the pattern. So spend a couple of minutes here on it here, see if you can see it. So what's the next number after that 1 up there, folks? 4. What's the next number?
2, 8, actually,
And then?
1.
Oh, no.
Because what's repeating?
And 1, 4, 2, 8, 5, 7.
Yeah, all 6 numbers, right? So 1/7 as a decimal is 0.142857, and all 6 of those numbers repeat over and over and over again. Okay? That is one of the worst numbers out there.
What idiot came up with that?
Uh-oh.
Just math.
That's just math. It's just math. Folks, the worst number to work with is 7s. They have the most possible repeating numbers, okay? They're, it's not awful, but it's the sort of thing that once you see it, you're like, well, it has to happen, okay, folks? Every fraction has to be able to convert it like this in some way, shape, or form. All right? Not bad? I want you guys to be able to see patterns, right? I mean, again, part of the reason why we care about patterns, folks, is that that's what everyone is doing right now. That's what business is doing to get profitable, is looking for patterns and taking advantage of it, right? That's what they do. So your job is to start getting used to looking for, seeing, and noticing patterns. Okay, so anyways, let's go the other way. If I give you a decimal, how do you write that as a fraction? Yeah, basically, my answer to students whenever they ask is, read the number. How do you read that number correctly? 3/10. Well, so how do you write 3/10 as a fraction? You just did, right, what you said, right? 3/10, okay? That's how it works. Which is nice, okay? So, let's try another one. Let's do, 0.012. Careful. Where does it get to? Right, so what is this number technically? 12 thousandths. And what are you guys going to do with the 12 thousandths? Reduce. How do you reduce fractions? Divide by like numbers, right? So what do you divide both of these by? Start with the easiest number if possible, right? 2. Since they're both even, folks, start with 2. That's always the way you do it first, right? Are we done? Why not? They're still both even. Keep doing 2's until they stop both being even. That's the easiest way to do it. Can we reduce it further? Nope. And we'll get to dealing with 3's in a little bit. Okay? So just realize that's the way it works. Now, one of the things that I like to show students just to be safe, instead of necessarily looking at where the number is, the other way that you can do this is basically say, hey, write the number that you have right here as the numerator. Okay? Whatever number this is, it goes up in the numerator without the decimal point. The number that goes below is always 1, and then there are 5 places after the decimal. Guess how many zeros there are? 5. Always works. Okay? And technically, though, normally you don't write 0, 0, 0, 13. You just write 13. So don't write the zeros if you don't have to. It's kind of weird. It's not wrong, though. Again, it's perfectly okay to put the zeros in there. It's actually mathematically correct. I wouldn't mark you wrong. I'd actually be, I'm okay with it. I'd also think you're weird, but that's okay. Being weird is perfectly okay in this class. It's math. You should expect weird. All right? All right, so not too bad? All right, so.
Is it wrong to put the comma in there?
No,
Do
if you
nominate?
if you wanted to put it in there, that's fine. You do or don't have to. I don't care one way or the other. I'm not a bank. Banks get anal about that. I don't. If you don't put your commas in between your hundreds and thousands, that's okay. If you do and you're very careful with it, that's great. Just please don't do things like this. You'd be surprised how many times I see numbers like this written down, right? It's 420,000. What did they do? They put the comma in the wrong spot. That, please don't do that. That just, I mean, I don't mark students wrong for it because it's not technically wrong to put the comma in the wrong spot, but it just really looks bad. I mean, I'd rather you didn't put the comma down than put it in the wrong spot. But again, if you want to put them in, it's okay. If you don't, it is also okay. It's the same way with leading zeros in a decimal. If you wanted to have a 0 in front of that 0, 1, 2, I'm okay with it. For me, I don't put it down there because I'm lazy. If I don't have to write something, why would I bother, right? And so I don't. If you want to put the 0 down there because it makes you feel more comfortable with your decimals, do it. Please. I am not going to mark you wrong. I just won't. Okay? All right? I'm not trying to make you into little mini-me's. That would be really weird. All right, so let's see. Yeah.
I'm looking at the second line you wrote there,
Uh-huh.
and it's easy for me to visualize what 250ths might mean. But it's not easy for me to visualize what 0.012 might mean.
Yeah.
Okay, say if I got that in some business report or something.
Right. Mm-hmm.
I know it's a small number, but I can't really visualize what it is.
Well, and that's why being able to convert it to a
Right.
fraction is not a bad thing to do, right? Because then you can actually see how small it really is. Right?
Exactly.
And so, and hopefully, as you do this class, you will get more and more comfortable with being able to go back and forth. Yeah. And seeing which ones are small and which ones are not, potentially. All right? Now, one more just to be safe. Write that as a fraction. And yes, there are more than one way to write this fraction. Note, you are more than welcome to do essentially what we did up here. Take the number, throw the decimal point away, and write the number down. It's okay? How many decimal places do I have? 3. How many zeros should I have? 3. Same thing, right? That is the improper fraction. There's nothing wrong with improper as long as I don't specifically say which way I want it. Or, how else could I write this? Yeah, 4 and 1 1,000, right? And either of those answers I would give full credit for, okay? As long as the directions don't tell you which form of a fraction it has to be, you're all good, okay? Alright, so, not too bad? Alright. So, we started on this a little bit, we touched on it already. We talked about reducing fractions. Okay, so, what we were doing when we were dealing with these reduction of fractions, what we were doing was applying something called too many illities, right? We were dealing with what we call in mathematics divisibility, right? Divisibility is one of those really great nerd words that if you can ever use in a sentence, you are immediately stamped nerd, right? Because it's divisibility. It's a 6-syllable word. Anytime you can get to a larger than 5-syllable word and use it correctly in a sentence, it's stamped on your forehead, okay, folks? It's a big N for nerd, right? And it's the good kind of nerd, though, right? So don't worry about it, right? So the reason when we can reduce fractions is when the numbers in the numerator and the denominator are both divisible by the same number, okay? And so what you need to do is to tell me what the rules are for when something is divisible by a value, right? So when is something divisible by 2? It's even, right? That's kind of the way we write it. What I'm going to do is write it in a slightly different way, a little bit wordier, but you're going to see why in a bit, right? If the last digit is divisible by 2. That's just a mathy way of writing even, folks, okay? It's not, I haven't done anything fancy. I haven't changed the definition of what it means to be divisible by 2. It's still even. That's just the mathy way we write it, okay? This rule, folks, anything with a red star, you should know, okay? I'd like to think you know these all already, but just in case, okay? This is the one that most students don't remember, although I'm sure you learned it at one point in time back in the day. When is a number divisible by 3? Anybody know this trick? It's a great parlor trick, folks. It's the sort of thing that can get you free drinks at a bar. And you don't have to flash any skin whatsoever. There you go, right? If the sum of the digits are divisible by 3. $162. That number is divisible by 3. Why? What's 1 plus 6 plus 2? 9. And you know that 9 is divisible by 3. Okay? That trick is so simple, folks. It works like a charm. Okay?
About some stuff.
Mm-hmm.
It's eels, not
I'll believe you.
Thank you.
No? All right.
It's like you and putting the papers in order.
No, I'm good with it. You can correct my spelling too, because there will be lots of misspelled words up here. And words that I make up on the fly that are math words for me, but not real words in the real world. So just bear with me a little bit. All right? So again, those sorts of things, right? So like this number, 468. You look at it and you think, well, why the heck is that divisible by 3? But now you know, right? What's 4 plus 6 plus 8? 18. Is 18 divisible by 3? Yeah. Okay? So what it does is it's basically breaking the problem down into the division being a much smaller number, which is easily done in our heads. Okay? So, again, nice, cool parlor trick if you ever need it. Alright? You will need to be able to do this without a calculator on the test. And I love 3s, folks, so don't be surprised. Alright? Now, 4. Note, I am not putting a star next to 4, folks. You don't need to memorize this, but it's an interesting little tidbit. Alright? That probably is R. If the last 2 digits are divisible by 4. Is 28 divisible by 4? Yes. 1,728 is divisible by 4. 1,375,128 is divisible by 4. Is any number that ends in 28, since the 28 is divisible by 4, the number is divisible by 4. Right? Now what I want you to see is kind of the similarity between 2 and 4. Right. When there's only a 2, we just look at the last digit, see if it's divisible by 2. 4 is 2 2s. So if it's 2 2s, we look at the last 2 digits and see if it's divisible by 4. Okay? Mm-hmm. There is a rule for 6. I'm not even going to worry about it, so let's just skip it. I do expect you to know the divisible by 5 rules. What does it mean? What do you need to be divisible by 5?
5 or 0.
Alright. Yep, 5 or 0. Alright, now what I want you guys to do, okay, is to continue the pattern that I started. Right? Pattern recognitions. These are one of the things that we get to here in the beginning part of this class. First off, what's the next number in this sequence? If I'm doing 2 is 1 2, 4 is 2 2s, 2 times 2. If I multiply by another 2, what number am I going to jump to next? That's if I'm adding, I'm multiplying. What's 4 times 2, folks?
8.
What's the rule for 8? Continue the pattern that I've started. Except by 8. Yeah, that's exactly the rule for 8. If the last 3 digits are divisible by 8. And what you see, again, math is loaded with this stuff, folks. And this is why math is such a big deal out there in the real world right now. It's not because you can necessarily do mathy crap. Okay, that's not necessarily what they're looking for. What they're looking for is you noticing things that are going to be profitable to a business. And this is the kind of crap that's profitable. Right? You don't think it is right now, but this is easily relatable to how many times does a certain someone go to the store? And you say, oh, well, they go twice a month. Well, what do you want? What does that store want you to do? They would love it if you would go 4 times a month. If you can see the pattern that makes them do it twice, you can manipulate them so they will go 4. And once you get a human being into a new pattern, guess what they do? They stick to it. Yeah. And that's what businesses have been doing for the past 20 years, to get you to buy more stuff.
That's what it's called.
Yeah, the boss is walking by, so I had to change that. But that's the idea, okay? And so technically, if I asked you to continue this pattern, what would you go to next?
9. Oh, 6.
16, right. Yeah, because we're multiplying by 2s, right? Since this is divisibility, the other thing that goes with it is multiplication. Division and multiplication are the 2 handholders, right? So it would be 2, 4, 8. Our next one would be 16, and what would be the rule? If the last 4 digits are divisible by 16. And folks, this is what computers use all over the place to simplify the math, okay? Because computers are always dealing in powers of 2, so they know they know everything about powers of 2. All of these rules are, very indicative of the computer-based world that we're living in right now. Okay, but for all intents and purposes, folks, what I want you to be able to do is to be able to do 2, 3, and 5 in your head without a calculator or on a piece of paper as needed. Okay, so reduce this fraction. Let's do 162 over 468. I strongly encourage doing these things in steps, folks, okay? And take the easiest steps first. What's the easiest number to work with? 2. Start there. Are both of these numbers even? Yes. Take them in half. What's half of 162? 81. What's half of 468? 234. Can we do more 2s? No, because 81 is unfortunately odd. So once you're done with 2s, what are we going to do next? 3s. What's 8 plus 1? 9. Awesome. What's 2 plus 3 plus 4? 9. These are both divisible by 3. 81 divided by 3. I'll do that one for you. 27. What's 234 divided by 3? 7, bring the 2, 24, 78. Am I done? Why not? What's 2 plus 7?
9.
What's 7 plus 8?
15 divided by
Both divisible by 3. We can go one more at least. Keep repeating, folks, okay? So don't stop after 1. 27 divided by 3. 78 divided by 3. 26. Are we done?
This 3 can go into 26 and 9.
3 can go into 26, because what's 2 plus 6?
2 plus 6, 8.
Can 3 go into 8?
No.
No. So we're done with 3s, folks.
Okay.
Can we deal with the 9 or the 26 anymore? Nope.
No.
This as simplified as we can get. Okay? So that's the kind of stuff I would expect you guys to be able to do. And again, if you have to sit down with a piece of paper and do the long division by hand because you can't do 234 divided by 3 in your head, there's nothing wrong with that. Okay? In fact, I encourage you to do that to make sure you don't screw it up, right? I mean, the problem I tend to see on the test is that students look at this and know that they can divide by 3, but then they wind up telling me that this is like 72 or 65 or some weird number that's not the correct one. Do it, okay? You know how to do good old long division. Just crank it out. You only got to do it once. That only happens on the first test, folks. After that, every test is 100% calculator all the time, okay? So just this one time. And again, the main reason why I did it is because a lot of companies have been telling us here that when they put jobs out for people, they'll get 40 or 50 qualified applicants for the position. And so the way they get rid of some applicants is they say, hey, here's a little math test. And ask them to do some math before they can even get into the second part of the interview. If you can't get at least 4 out of 5 of those right, they ask you to leave. So just be careful.
So I understand what you said by attack it by using the easiest digit first.
Mm-hmm.
But we could have used the law we just learned, or the rule we just learned about when is something divisible by 3.
Yeah, we could have started with 3, but it's much easier to deal with 3 after we've gotten rid of the 2s. We could have started with 3. There's nothing wrong with it. You could have done 3 first. It's okay, but my point to you is do the 2s first.
Okay.
Because dividing by 2, cutting things in half, is easier than cutting things in thirds. Okay? I mean, in general, it is. All right? And once you cut things in half, you make the number smaller, and then dividing by 3 is a little bit easier. So that's my recommendation. But you didn't have to do this. You could have done 3s right off the bat if you wanted to. It would have gotten you to the same answer.
Is there a way we could have used that rule to figure out we could divide by 18?
18 to be divisible by 18. Technically, what it means is you have to be divisible by 9 and 2. But we won't. I mean, going down that road
We're
is
not that far.
yeah.
yet.
We
won't get that.
Yeah, we won't go down that road because what I would more want you to do is to deal with the 2s and the 3s than dealing with a rule for 18. But there are rules like this for 9 and 18 and larger numbers. But they tend to all point back to the earlier ones we worked on.
Right, and I just saw that by multiplying.
2 and 3 and 3.
Right,
Mhm.
right. And then I was wondering, is there a way to figure out right away it's 18? But we're not there.
Yeah, there is, but I don't want to go down that road. Just so you know. All right? So the idea, though, is, folks, realize you got to reduce fractions, okay? Anytime you write a fraction in this class, you reduce it, okay? Yes, I know sometimes the book says in the homework, don't reduce the fraction, but stupid book. You should always reduce your fractions all the time, always, no matter what. Okay, so, all right, so we can go back and forth. We can then move on to the next step. You should be able to add decimals, folks. Okay, I mean, so if I told you to add 127.1 plus 4.57 plus 0.0761 plus 3.14 plus 22.5. So if I asked you to add up all of those decimals, how would you do it? Again, no calculator available. What do you do to add decimals, folks?
Line up the decimals, stack them on top of each other.
Yeah, line up the decimals, stack them on top of each other, right? So 127.1 plus 4.57 plus 0.0761 plus 3.14 plus 22.5. Now, the problem now, though, is which numbers are in which columns. Have you written them neatly enough to be able to tell? Hopefully you have. Folks, when I was a kid, I was the worst penmanship person in the world. I had terrible penmanship. It was awful. Okay? And so what they did in order to convince me that I needed to do more was to show me that I couldn't add these numbers when I wrote so poorly. And so I was like, oh, crap. What do I do? So my teacher said, hey, when you're dealing with these numbers, fill in zeros if you need to, just to be safe, right? So if you know they're all going to have 4 decimals, you can say, hey, I've got 1, I need 3 more. I've got 2, I need 2 more, right? There is nothing wrong with doing that so that you can guarantee the numbers all line up, okay? You know you can put in as many zeros as you like, just do it, okay? And honestly, that's what it took for me. Well, actually, it didn't work for me. I wound up using graph paper to add because it forced me to write the number in a little box, and the boxes were guaranteed to be lined up, and that's what it took for me, literally. And it actually forced me to write my numbers the same size. I was a little minor dyslexia when I was a kid. I used to write numbers like this. My zeros were always huge compared to all my other numbers. And 7s were even worse, right? Literally, that's the way my numbers looked on my papers, right? I just, for whatever reason, zeros had to be these big numbers. Don't ask me why, but that's what happened. And so until I got graph paper and was forced to figure out how to put a 0 in a little square box, I couldn't do it. It took me, I think, probably a good 6 months of 5th grade or 4th grade math, whenever you did this, to get it. And it literally came down to buying graph paper. So, regardless, be neat. All right? And then when you add, folks, just don't forget, right? 1, 6, 18. Don't forget to carry your 1s, right? 2, 7, 8, 13, carry your 1. 8, 12, 15, 17, carry your 1. Be careful. 157 and 3,861 10,000s. Okay? Line the decimals up. Okay? I don't need to do another one, do I? Okay. Again, I just like to be safe. And then if you can add, what else do you have to be able to do? You got to be able to subtract. So what's 7 minus 3.853476? Please, 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 pretty please, do not tell me that the answer is 4.853476. You'd be surprised how many people do that to me under a test situation. They get nervous and go, sweet, I know what 7 minus 3 is, it's 4. And then just add the decimals. Please do not do that, right? What do I do to subtract these, folks? Exactly. Get as many zeros as you need in the 7. So that you have one covering every one of your numbers in 3.853476. And then what do I do to subtract? A whole lot of borrowing. So how does the borrowing wind itself out? What's the 7 going to become? Okay, don't forget to borrow 1 from the 7 first of all, right? What is the 0 going to become? It's a 10, but then what am I going to have to do to that 10?
So it becomes 4 or 5? Oh.
It's going to be 10, but you're going to have to borrow 1 from that 10 to make this next one a 10, so it goes down to a 9. Same thing happens here. It becomes a 10, but you need to borrow 1 to turn that one into a 10. It goes down to a 9. Rinse and repeat. Okay? So that all of these things become 9s until you get to the very last one. That's an actual 10. Okay? Again, this is, you did this back in 3rd or 4th grade, subtracting regular old numbers. This works the same as with whole numbers as it does with decimals. Okay? So if you were trying to take 7 million and subtract 3,853,476, you'd do it exactly the same way. Okay? And then it's just subtract, right? So 4, 2, 5, 6, 4, 1, 3. Alright? And that's just you guys being careful and not forgetting how to do your basic arithmetic, okay? Yes? Okay. So, one last thing. On subtraction. I have $25.36 in my checking account. I write a check for $31.13. Suppose I have forgiveness on my particular checking account that will allow me to have negative balances. So there are new checking accounts out there, folks, that will temporarily allow you to have negative balances. A lot of them will actually draw money from your savings account at the end of the day in order to zero it out. Others of them will give you like a 4-day grace period for you to actually deposit money before they start dinging you with fees and overcharges, etc., etc. Banks have started to get a little bit nicer about that kind of stuff. They're still jerks, don't get me wrong, but, you know. How will you figure out how much is left here, folks? What are you going to do? Subtract. What are you going to subtract from? And
2536 minus the 3113.
And how are you going to do that by hand?
Well, you do the 6 minus 3 is the 3.
Be careful. Wait a second. Now so what you're trying to do is this, right? And And this is one of the problems with our educational system, folks, is that that is impossible. You cannot do it that way. It won't work. Okay? Right? This technique, which we've been learning how to do adding and subtracting forever, technically does not work if you're subtracting to become a negative number.
I got 14.
How do you get that?
Subtracted 31, 13 minus 26.
Exactly. You utilize the fact that you subtract the other direction, and then you make the answer negative at the end. Okay?
Like your bank statement at the back.
That's absolutely right, right? I mean, this is...
been unfortunate enough to see that.
So note, it's not wrong to write this, but folks, this is our standard method of subtracting does not work when this happens. All right? It's one of those things that, it's one of the reasons why they started to try and come up with the whole Common Core concept, was because this technique, which we use all the time, technically doesn't work all the time. Right? You have to know this little trick in order to do it, right? So, 13 minus 6 gives you 7. Borrow 1 from the 1 to make it a 10, so that becomes a 7. Borrow 1 from the 2 to make that a 10. 10 minus 5. Negative 577. Because you switched the order. And technically what you're doing there is actually applying a very deep algebraic identity, right? What you applied right there is that. Yeah. But nobody knows that we do it, right? But technically that's what you did. All right? And that's an extremely deep algebraic understanding concept. And again, this is why we were trying to, as mathematicians, come up with better ways to teach math at the first, second, and third grade level so that students wouldn't try and do this because it doesn't work, right? Our technique of subtraction doesn't work unless you play this game, and that's tricky, right? How do you explain that to a 6-year-old? Here's some really 7th, 8th, minimum 7th or 8th grade algebra that you need to understand in order to do this. Right? But we learn negative numbers when we're in 5th or 6th grade, right? Because we have to start learning about debt because we have to. All right, so again, just be careful with those sorts of things. All right? Now, bad? So if we can add and subtract, we got to multiply and divide. So how do we multiply, folks? What was that, Monroe?
You don't have to line up the decimals.
Very good. Thank you. Please note, in fact, what I tend to tell students is when you do the multiplication, do it without the decimals there at all. Just multiply the two numbers. 245 times 16. And do multiplication the old-fashioned way, right? 6 times 5 is 30. Carry your 3. 6 times 4 is 24, plus 3 is 27, carry your 2. 6 times 2 is 12, plus 2 is 14. Be careful when multiplying by the 1. Remember that it's really 10. That's why you put a 0 at the bottom, right? Because that 1 is in the tens place, so you want to be in the tens place to start with. And then add. And then put the decimal in at the end. All right? Two decimals here, 1 decimal there. What's 2 plus 1, folks? 3. Yep. 2 plus 1 equals 3 decimals. 3.920, or you can throw the 0 away. 3.92, perfectly acceptable answer. Okay? So again, please note, when multiplying decimals, theoretically, don't even bother with the decimal points until the very end. Okay? And then just to be safe and to sort of show you the point here to some degree, What is 0.052 times 0.0014? We'll keep the numbers relatively simple still. Again, you're just going to multiply the numbers without the decimal. Note that leading zeros without the decimal, they're nothing, right? So all you're really going to do is multiply 52 and 14. Four times 2 is 8, 4 times 5 is 20, 0 and 52, 728. But now how many decimals do I need? 3 decimals there, 4 decimals there, 7. So 7 to 8 with 7 decimals. Right now I've got 3 numbers. How many more? 4 more? 7 decimal places, okay? Again, that's the way you do it without the calculator. It is. It's foundational is what it is.
Yeah.
That's perhaps a slightly better word.
Yeah.
All right, so we can multiply? All right, so the drum roll. You got to be able to divide too. All right. So let's suppose I ask you to divide let's keep it relatively straightforward. 6 divided by 1.6. This is a little bit older school. Again, you're taking 4.6 and dividing it by 1.6. All right, so you're dividing into 4.6. So 4.6 goes in the house. 1.6 is outside the house. Please keep those straight. That tends to be the thing that students do, is get them in the wrong order. And remember, when we were dividing by decimals, folks, what we're dividing on the outside of the house is never a decimal. Okay? So what you do before you start is you move this decimal over however many times you need to make it a whole number. And then you do the exact same thing on the inside, the same number of hops, not the same thing, right? If you had to do 1 hop on the outside, you do 1 hop on the inside, and that's where the decimal point goes, okay? So it's the number of hops have to be the same, not that they both have to be whole numbers. It happened to in this case just because it was lucky. But then you just do good old long division, right? How many times does 16 go into 46? Boom. Follow the steps, right? So we can start with 2. And what are you going to do if you don't have a 0 at the bottom? Yep, add as many as you need, right? How many times does 16 go into 140? Ooh. What is that? 7 or 8? It's got to be 8, right? 8 times 6 is 48. Carry your 4, 128. Need one more 0, and last but not least, how many times? Oh, not quite least. How many times does 16 go into 120? 7 times, because 8 gives you 128. $112, and here's the last one. Because then you get an 8 and a 0, and how many times does 16 go into 80? Straight up 5. 2.875. 2 and 875 thousandths. Okay? That's the technique. It's basically just going back to doing old, long division, except you have to play with the decimal a little bit first. All right, so let's try one that's a little bit different. Let's do 2.2 divided by 0.005. Again, remember, you're dividing 0.005 into 2.2. So now, how many times do I have to move that decimal? 3, right? If I hopped it 3 times, what do I have to do in the house? 3 hops, right? 1, 2, 3. Here's my decimal point. What do I put into those blank spots? Zeros, right? Again, that's what happens when you move the decimal around. And really what we're doing is dividing 5 into 2,200. That's all you're really trying to do. All right? And this one should be relatively quick, right? How many times does 5 go into 22? 4. How many times does 5 go into 20? Just don't forget you haven't made it to the decimal point yet, right? Here's the decimal point. Don't forget that 0 that comes out after the 4, right? So it's 440, not 44, right? And this is one of those truisms of mathematics. When you divide by really, really, really small decimals, you're really multiplying by a really, really big number, right? Because when you divide by a fraction, you're really multiplying by its reciprocal. So you should expect it to be a much bigger number. All right. Let's do one more, and then we'll call it a day on division, okay? This one always just makes me a little bit nervous, right? So let's do 0.0086 divided by 0.4. Just do one more, and then we'll go on to word problems. So, how many times do I hop? Just once. So inside, I hop just once. Here's my decimal point, right? So how many times does 4 go into that leading 0? 0. Don't lose the leading 0, right? How many times does 4 go into 8? 2. Remember, when it's zeroed out, if you've still got numbers, you got to keep going, right? How many times does 4 go into 6? 1. And don't forget you get a free 0. 0.0215. Okay? Okay, thank you for indulging me a little bit. Again, this is the sort of thing, folks, where I strongly recommend that you do some of the homework problems with this in mind, because you're going to have to do it on the test, right? So do it a couple of times, and then when you're done with it, pull out your calculator and check. It's really easy. I mean, don't piss away points for nothing, right? I mean, I like the principle, but keep getting the correct points, right? All right? All right, so a couple of quick word problems, okay? So I can buy, let's see, let's make it weirder than that. Let's suppose I can buy 7 coffees for $9.65, or 11 coffees for, let's say, $13.98. Which is a better deal? How would you figure this one out, folks? Divide them. What are you going to divide by?
7 into 965 to get what it would cost for each one, and the 11 and the 13.98 to see what it cost each one, and then the lowest price is the better deal.
Find cost per coffee, right? How much does it cost to buy basically 1 cup of coffee? And that will be what you're looking for, right? What does the word per tell you to do in mathematics? Divide, which is exactly what you were saying, okay? And note that the order it goes, right? It's cost divided by the coffees, right? So you're going to take the money divided by 7, right? 9.65 divided by 7. If you had to do this by hand, seven divided into 9.65. 7's a nice whole number. We don't need to fix anything. How many times does 7 go into 9? 1. How many times does 7 go into 26? How many times does 7 go into 55? 7. 49. Now, this is money, folks. Where do you always round money? To the penny, right? Generally speaking, okay? Do I know, is my rounding $1.37? Do I know? Not quite. You got to go 1 past, right? So how many times does 7 go into 60? 8 times. Now you can actually stop because now you can round it to the nearest penny, okay? If you are dividing numbers where you know you round, don't go forever, okay? You know, you could keep going until you find the repeating decimal pattern. That would be fun, but it's a little too much fun. I don't know if you can handle the peril. So please, just tell me that this thing is approximately $1.38 per coffee, right? And then do the same thing with the other one. Figure out what its cost per coffee is. Tell me which one's cheaper. That's the winner. Okay? So, I know we're sort of out of time, so I apologize a little bit. Really fast. 11 into 13.98. Did it wind up being better?
Yeah.
Oh yeah, because then it's 2, right?
Sometimes in advertisements, stores or companies will do this, and if you do the math, you can see sometimes it's the exact same price for
Yep.
their item.
Yep.
They're hoping to fool you to buy more,
Of
just to
course. Yeah, that's 1 for $5, 4 for 20.
see. Exactly.
Fun. That's very the Girl Scouts do it all the time, right? They're like 1 for 1, you know, 1 box for 3, 5 for 15.
Half the time when you check out, they still give you the deal if you just buy one.
Yeah, yeah, true. So anyways, folks, don't forget for next time, please work on the homework. Please note, skip 38 and 40. Talks about rounding all the way. We didn't talk about it in class, and I honestly don't care about it, so please just go ahead and skip those 2.
Does it say that online?
Yeah, it says it online. If you look at the online homework, it says the same thing. But note, it goes up to 84. There's a lot of problems. Please don't wait to the last minute to work on this.
Glitter me this week.
Well, that's because we only had 1 class, so.
Yeah.
All right. So, anyways, on Monday next week, we will kind of get into the flow of how a week is really going to happen in this class. Because what I plan on doing at the beginning of class on Monday is reviewing everything we did in chapters 2 and 3 before we start moving into the next chapter. Normally, that's what I will start doing. Normally, Mondays are dedicated to asking homework questions, reviewing what we did last week, and then, if there's time left, starting on the new material. We really haven't had a normal week yet, but hopefully next week will be sort of normal. Assuming we don't have a snow day. All right, thanks everybody.
Oh, that's right. Stop.